Hey guys, Andre Freeman here. This quick video will show some key ideas for Project 1 in Math 1200. This is the project related to Module 5 and linear regression. So we're in the Module 5 folder in Blackboard, and when you click on the project description, the description and the guidelines come up, and this document outlines the key ideas. The key is that you can use a data set that's already preloaded into this web app, analyze it, and answer the questions below. Or if you prefer, you can get data from the internet that is of a topic that interests you, copy and paste the data into this web app, and then do the project that way. Let's go through some examples. So when we click on this link, the website opens up. And as I mentioned, this website has preloaded data on different topics. So here we have a scatter plot showing the relationship between tomato meter score and audience score for 125 movies. And if you click on each one of these cells, one of these ordered pairs or points, you see the name of the movie. So here, this is The Hobbit, The Battle of the Five Armies. And you see how this movie has a tomato meter score of 61. That's shown in the table on the left over here. And that movie, if I can find it again, The Hobbit. Let's see, can I find it again? It's okay. If we click on any of these movies, you see the tomato meter score on the left, the audience score, and there's also other variables as well. So this particular scatter plot shows a overall positive relationship. As tomato meter score increases, audience score also tends to get higher. If we click on regression line, we can see that the regression line in blue here has a positive slope. The slope of the regression line is 0.479, and the y-intercept is 35.5. We can interpret each of these values, these parameters, in the linear model. So by clicking on regression line, not only do you get a graph of the regression line, but you also get the equation. And we also get the correlation coefficient, which here is 0.697. Again, that also confirms that there's a positive relationship and that there is a moderate, strong linear relationship between the two variables. So I don't want you guys to pick this particular relationship between two variables, because you can select other variables. So using this drop-down menu, we can change, let's say, to IMD. So now we're looking at the relationship between tomato meter and IMD. So these would be the two variables. So each of these films has a tomato meter score and IMD score. We can explore the relationship. We can also change tomato meter, let's say Metacritic user, for example. And now we have a different set of two variables, right? Metacritic user is the X variable, or the explanatory. IMD would be the response variable, and we can explore the relationship. Notice how the equation has changed because we have a different data set, and the correlation coefficient also has changed based on the changing these two variables. Now, you're not limited to just looking at movie data. We can go look at some other data sets. So, for example, mountain bikes. This is a pretty straightforward one to understand. Each of these dots corresponds to a mountain bike. And here we're looking at the relationship between weight and price. And again, we have our regression line equation. We also can look at the correlation coefficient. We can interpret these parameters. So this is the idea if you choose option A. You essentially look at the data set options. You pick one, for example, animal and longevity. And then in some cases, you can change the variables that you're going to work with. Some have more flexibility, others have less. Here we're looking at animals, 21 animals, and the relationship between gestation, the number of days it takes for the animal between, I guess, conception and when it's born. I'm not an expert on this, but gestation, and longevity of how many years on average the animal lives. We can, of course, do something else. Let's look at cell phone specs. What are we looking at here? Now we have battery capacity and weight for cell phones, and we can look at other quantitative variables here and change them. So again, if you use this first option, you will pick a data set, pick the two variables, and then you'll describe what you see and interpret what you see. The second option is more challenging. In the second option, you have to actually pick or get data from the internet. Now, there are some possible sources for this. One source would be if you go to like Kaggle, the website Kaggle. They have a lot of data sets. Some do Kaggle data sets. So Kaggle is an open source website that has different types of data sets. And if we click on one of these, for example, let's say, let's try, this is obviously more work because you have to actually look to see what data is there. So here we have coffee sales. Let's see if we can find two variables that are quantitative. We have variables here, but they're not all quantitative. We have hour of day for the transaction, coffee name. This is an interesting data set, but this may not be the best option for the project. So again, this is the more challenging task when you're getting data set off the internet. You're looking for quantitative data where you have essentially two columns, and then you can just paste into the website. Now let's look at a different example. Here, I'm looking at this. I'm Googling Lock5 datasets. This is a nice website that you can go to where you can download Excel files of datasets and then use the Excel files to get the data to then copy and paste to do an analysis. So let me show you an example of this. Kaggle is great, but and has a really great opportunities, but Lock5 datasets will be probably simpler for many of you to utilize if you choose to do this for the project. So when we go to this website here, again, you can just Google Lock5 datasets and it'll come right up. And if we go to, for example, to the third edition, we have these different datasets we can play with. I'm going to go to, for example, Baseball Hits 2019. I click on the Excel file that then downloads to your computer. And when you open up the Excel file, you'll see a data set that has quantitative variables for, in this case, baseball teams. So here, if we analyze this quickly, we can see that each of the rows corresponds to a team. So this appears to be the Arizona, I believe, Diamondbacks. And it's the league that they're in, National League versus American, number of wins, runs, hits, and so forth. So this is a pretty nice data set to use for the project because you can just click on two of these columns and copy the data. Notice that each of these, when we click on a column, we have complete data. There's nothing incomplete. And that could be an issue if you have a data set that hasn't been cleaned and there's empty cells. When you then copy and paste into the web app that we just used, you may have an error. But in this case, this is a pretty simple data set. There's only 31 rows altogether. The first row contains the variable names or the headings. So let's, for example, look at, is there a relationship between the number of wins a team has during the season? This is from 2019. These are, again, professional baseball teams. And the number of runs scored during that season. So these values are based on the entire season. Well, I highlight these two columns. I click copy. We then go back to the web app here. And in this web app, let's just reset this web app. In this web app, we're going to enter data. We're going to do enter own. So this is where we're not going to use one of the preloaded data sets, which you could do. Instead, we're going to enter in our own data. So enter own. We can then click Control V to paste in the data. We have wins and runs. Notice how this first row has that, but I don't think that's going to prevent anything from happening here. So wins, runs, and we just click submit. And the website is basically ignoring this first row. And look, we have a scatter plot. The scatter plot shows 30 points. We can again see a positive relationship between the number of wins a team has and the number of runs they scored over that season. We can click on the regression line to get the graph of the regression line and the equation. There's also the correlation coefficient. So now we would answer project questions based on this data set if we made this option. Going back at looking at the questions in the project, you want to just really carefully go through each of these questions and really make sure that you're comfortably and correctly interpreting the correlation coefficient, the slope, the intercept of the regression equation. These things are all introduced in Lumen in the Module 5 study plan when you go through those problems. But if you have a question, of course, you can always send me an email, and I'm happy to assist you. So again, you have two options, guys, for how you can proceed with this project. And I hope this makes sense. Option one is a lot simpler, certainly, if you just go to the web app, and rather than entering your own data, just pick one of the preloaded data sets that come from the corresponding textbook. Option two, as you can see, is also very interesting and allows you to pick data that you may find interesting from off the internet. And again, this Lock5 Datasets website is a great choice if you would like to quickly look at data sets that have corresponding Excel spreadsheets for you to play with.